Bill is visiting the University of Nova Gorica as a Fulbright scholar, so he's with us for the following 6 months, and we're very happy about that. Today, he was so kind to give a lecture on a very important topic that concerns everyone, and that is climate change. So, although the debate is very, heated and loaded with emotion and political ambitions, I think that this important topic deserves scientific treatment, where arguments and different points of view can be considered scientifically. So, Bill, please.
Thank you. And thank you all for coming. I appreciate it very much. It's very nice to be here. I'm very honored to be here. So we'll start. You can see that this is something we've been talking about for a very long time. Skeptics. My background's in physics, and properly, I think all physicists should be skeptics. We should look at things, examine them, filter them, through what we know, and decide. And that's what I'm going to ask you to do tonight. You don't have to believe anything I tell you, but if you don't believe me, go out and look for yourself. Read the papers and decide for yourself. Okay? And I think you'll come to the same conclusions that I have. My normal research area is in the lower part of the atmosphere, so I'm very much interested in the available energy at the surface and how it gets partitioned and what the net result of that is. So what happens with global warming is sort of a natural interest, and I can assure you I am not paid by Exxon or anybody else for anything. Okay, I do my research in the lower part of the boundary layer, and that's what I do. But this is interesting to me, and what I find is disturbing to me. Okay, let's start out with something provocative. I'm going to basically say that almost all of the last 10,000 years have been warmer than it is today. And I know you've just finished getting lectured on how last year was the warmest year ever, right? Well, this is a temperature record from the Greenland ice sheet, and here's today. And I want to make a couple of points, not just that most of the last 10,000 years have been warmer, but you notice how the temperature goes up and down. We have no explanation for why any of those went up or went down, except this one. And we're 99.7% sure that that one's caused by humans and carbon dioxide. Okay, I have some really good beachfront property for you. Okay. All right. What I want you to notice is this is called the Little Ice Age. It's the roughly third coldest time in the last 10,000 years, and we started coming out of it about 1800. All right? And hopefully the temperature rise here is natural, and it means we're coming out of an ice age. What we really don't want to have happen is this thing takes the nosedive. Okay? And normally, these interglacial periods last about 8,000 years, so at 10,000 years, we're 2,000 years past. Okay, we're due for an ice age. All right, so let's start with some things we agree. The temperatures are probably rising. The climate problem is extremely complex, and it's actually classified as a wicked problem. Most times when we talk about things in physics, we try to hold all the variables constant and change just one so we can see how the system reacts. And the problem with climate is if you change just one thing, every other variable changes. And that's extremely hard to model and understand. CO2 levels are increasing, no question, and the greenhouse effect is real. It's a physical process, no question. However, I stipulate that the CO2 is increasing because of human intervention. The temperatures are probably rising. We're probably coming out of this little ice age. But we don't really know much about temperatures, and I'll come back to that. And we don't really know why the temperatures are rising. But CO2, an increase in CO2 should cause an increase in temperature. No problem, that's physics. What we know about climate is poor. And in fact, in the last month, a paper came out saying that our ability to measure, to predict things like El Nino and the Pacific Decadal Oscillation is actually worse now than it was 20 years ago. You know, we're not having a good discussion of climate and the things that happen in climate. Models don't work very well. I'm going to show you that the claims of disaster from elevated temperatures don't seem to be there. And not for here, but I will, if you really want to discuss this, we can. The solutions for our problem of CO2 are particularly ill-advised. Okay. The global warming idea depends on a couple of ideas that have to occur, and they're chained. First is that if we double CO2, the temperature will increase. And everybody with a scientific background will agree with that. We may disagree on how much, but we all agree that it will raise the temperature. Then it's stipulated that feedbacks as a result of this small increase in temperature will get magnified. Okay? And so this is going to magnify the temperature increase we see from CO2, and that's going to result in catastrophic warming that's going to, in turn, cause all kinds of terrible things to happen. And what I'm going to do tonight is go through each of these and then also look at the observations and let's see what they tell us. All right? So let's start with doubling CO2. And I apologize for equations, but and I'll show this one twice, but it's an easy one. For our discussion right now, we're going to ignore this part in brackets. And what we want to know is what the change in temperature is going to be if I have a change in forcing, in the amount of available energy at the surface. And we all stipulate that increasing CO2 will cause an increase in downwelling long-wave radiation, so there'll be more energy available at the surface. We quibble a little bit with the value of this number, but to first order, 3.7 watts is fine. Okay? It's not worth fighting over. Now, what's at issue is if we have this much forcing, there's a constant here that'll give us the temperature. And what is that constant? Okay? And the product of these two will give us the temperature rise for an increase in CO2. Well, these gray areas are the areas that the IPCC, the Intergovernmental Panel on Climate Change. So when you read that there's been a new report out, these are the guys that do it. And these are the values for that constant that they show, and these are a whole bunch of measured values based on, things that have happened in the past. And you see they don't agree very well. And another way of showing this is I'm sorry, I should have. The current value is here from the last report. Earlier reports put it out much farther out. But you see, even at this one, the actual measured values are much less. And so, while we all agree that the temperature is going to increase, I'm going to argue that even currently, the IPCC overestimates that amount of increase just from doubling CO2 by a factor of at least 2. All right? Well, then we're going to have feedbacks that multiply this, make it worse. So here we're talking about this term, and this term to the -1 power gets divided into here, so that if I have a positive feedback, that's going to make this whole number a little bit smaller. So when I divide it into this one, it's going to increase the temperature. So positive feedbacks increase temperature, negative feedbacks will decrease it. And so the question is what are these feedbacks? Well, when we start talking about forcing, this is the kind of picture, this comes right out of the IPCC reports. The problem is that there's an 800-pound gorilla in this room, and it doesn't respond to anything that humans do, and that's water vapor. By far, water vapor is the most important greenhouse gas. And how important? It's 100 times this. It's 100 times that. Okay? And again, we can't do anything about water vapor. Now here's the problem. The climate change people believe that increased CO2 leads to warming. Okay, we all agree. But more warming means we're going to have more evaporation. More evaporation means we put more water vapor in the air, and as I said, it's 100 times more powerful than CO2, so it gets a lot warmer. So there's more evaporation, okay, and it gets warmer again, and this thing should be runaway, and the next thing you know, we're Venus. Okay? But the problem is that hasn't happened, and it's never happened in history. And the question is why? And the reason is that the feedbacks are complex. Sure, if we add water vapor to the atmosphere, it's a greenhouse gas, a very powerful one, and it's going to make it warmer. But more water also leads to more clouds, and clouds reflect sunlight. It leads to more snow and ice, which reflects sunlight. But clouds also warm. I mean, if you think about the wintertime, the days when it's really, really cold are days when you can see the stars. There's no low clouds. Okay, so clouds also warm the surface. It's complex. And this is a hard problem again. But I'm going to claim that we don't even know the sign of all of the, we add up all the forcings from water vapor, we don't even know the sign, much less the value of the feedbacks. That's a problem. That's a problem. And as I'll show you, the climate models have net positive, very large net positive feedbacks. This one is kind of an interesting graph. You notice that all of the graphs are the same except for one. And all of these are outputs of computer models. And what it is this is the change in sea surface temperature, and this is the outgoing radiation at the top of the atmosphere. And this is taken by modelers to be a measure of the feedbacks. Okay, so as the surface temperature increases, the amount of energy at the top of the atmosphere decreases. So that means it gets warmer. Okay, there's less energy escaping into space. And you notice the models all predict the same sort of behavior. This graph is different. It's actual data. It's from the ERBE satellite, the Earth Radiation Budget Experiment satellite. And it shows going the other way. And what this would imply is that we actually have the sign, the total sign on our models for feedbacks at least, going in the wrong direction. Okay, the net should probably not be positive, but negative. Okay, so just sort of, we agree that increasing CO2 leads to higher temperatures, undisputed. The problem is how much? And I'm going to basically leave you with the fact that we don't have a clue, not really. Okay? The climate models failing to predict what happens, they overpredict the rate of change by a factor of 2. And actually, it's worse than this. The climate modelers traditionally give this curve as the difference between this year, the value this year, and some average period of time, some period of time designated as 0. What they don't show is the absolute temperature. And the problem is that the climate models actually overpredict the temperature by about a degree to a degree and a half. So if you actually wanted to show what the models are actually showing us, you'd actually have this same graph, but it would be way up here. Okay, not doing very well. This one's a devastating one, actually. This was postulated to be the fingerprint for global warming. And what it is this is the south, toward the South Pole, this is toward the North Pole, and this is height in the atmosphere. And so over the oceans, near the equator, there's a lot of water, and there'll be a lot of water vapor in the atmosphere, and that's going to absorb radiation, and it's going to make the upper atmosphere very hot. Okay? And this was the fingerprint, of global warming. This is another picture, a little smoothed, but here's what reality is. There's no fingerprint. All right, so I don't know how many of you are physicists, but physicists like to do back-of-the-envelope calculations, so we're going to do one here. And you could do this. It takes you about 15 minutes on Excel. We're going to take the IPCC's forcing as gospel, and their estimates for how much warming will occur, and just plot it out. As we increase the carbon dioxide, the temperature is going to go up by a certain amount. And this is the baseline amount, that F times lambda from that equation. No feedback. And if we add some of the feedback numbers they've suggested, and sometimes we get up to 10 degrees change for a doubling in CO2, we start out today and we see this is what's going to happen. All right. Well, let's project it back in time. 100 years ago, we had carbon dioxide concentrations of about 280 parts per million. So let's put it back in time and see what it says. Well, even accepting what the IPCC says, that we've had 0.7 of a degree of warming, that's more in line with having no feedback than it is with the others. That if we really were this sensitive to a small injection of CO2, we should have seen a whole lot more warming by now. Just a little back-of-the-envelope calculation that just sort of, sanity check kind of thing. Okay. So I mentioned that if you believe that the world has changed by 0.7 of a degree in the last century, let's look at that. The first thing is this is the United States Historical Climate Network. This is the stations in the United States. The first thing I want to point out is that only 10% of them are good to a degree. And fully 70% of them are not reliable to 2 degrees. And these are ones in the United States that are manned by people from universities and federal government organizations, people that should know how to do this. All right? So when we start talking about something in, the middle of Siberia or middle of Africa or wherever, the reliability is going to be even less, even worse. We have another problem, and that is where you measure. These two places are just 67 miles apart, about 100 kilometers. So they really should be measuring the same thing. This one's in a parking lot in a fairly urban area, and you see we see a very warming trend. This one is in a rural setting, and many of the rural settings actually show decreases in temperature. Okay? And if you actually look and you aggregate stations, this is population density, and this is the temperature trend, the increase in temperature per decade. And what you see is that the more population you have, the greater the increase in temperature. And as you get to be extremely rural areas, we're way down here. All right? Well, okay, so we have temperatures that have problems. So we're going to adjust them. Okay? Now, the way this works is that somebody makes a measurement, and the red one is the raw measurement. This one is from Alaska. And they go to NOAA, and they go into the Global Historical Climate Network, and NOAA looks at them, and they decide what needs adjusting. And so this is the adjusted temperature. I can show you hundreds of these, and they all go in the same direction. Okay? I can think off the top of my head of only one that goes in the other direction, and that's the one for Central Park in New York City. All right. And it's even worse. This one here is from New Zealand. And New Zealand has 7 stations, and they have a National Weather Service that accumulates these stations and does their own adjustments before sending it to NOAA. And this is the adjustments of the weather people in New Zealand before sending it to NOAA for adjustment. Okay? And you should notice the kind of magnitude of these adjustments. This one is 12 even, this is 11.5, so it's like 3/4 of a degree adjustment. All right, so in the year 2000, these are the adjustments that were made to the overall total global historical network. You see it's about a little less 5, maybe a half a degree of adjustment. Okay? And then between 2000 and 2007, we did some more. And actually, since 2000, it's been systematic that we cool the past and warm the present. And you see that we've added another 4/10 of a degree, maybe 3/10 of a degree on average to the slope. And in the last 7 or 8 years, we've done some more, another 1/10 down, another 1/10 up. So now we're talking more than a degree of adjustment to the record. Okay? And yet, people will tell you that last year was the warmest year on record because it was 7/1000 of a degree warmer than any other year. Okay. Because of this problem, people actually download all the different temperature sets, data sets every day and check them. And I don't know, me being foolish sort of figured that the temperature in 1917 was probably fixed in 1918. But you see that we need to adjust them almost once a month. And it seems excessive to me. And so, in part of this, actually, there's some method to the madness. This is a temperature peak, and I believe that it's associated with the Pacific Decadal Oscillation. We'll talk about that a bit in a minute. But you see, here we're almost 9/10 of a degree, and down here we're about 1/4 of a degree. And that's what we thought in 1970. In 1980, this is the dip that's here. And you see we're down to about 1/10. And if you notice the red line and the blue line, as we keep adjusting the data, we now have the blue line higher than the red line. Okay? Odd. And if you look at one of the older temperatures, and then also look at one of the newer temperatures, what you find, this one here is for January 2000, this is for January 1915, and you see very systematically over time, this is 2008 to 2013, it's been adjusted down. And the present temperature has been adjusted up. It's very systematic. And if I ask somebody to measure something, and then I ask somebody else to measure it, and we average them, half of them would go up and half would go down, right? So when things get very systematic, you have to wonder. And then just in the last 2 weeks, we've had this happen. One of the researchers at the NOAA unit in Asheville, North Carolina, has come forward. What happened is just before the Paris meeting, a year ago, NOAA released a new temperature data set that showed a whole lot of increased warming in the last 20 years. And basically what this guy did is reveal how they did it and reveal it, these set of adjustments, as an outright fraud. And sorry, no comment. And since this is December 2016, this is the hottest year ever, I'm just going to ask you to look at this place right here in Central Africa, and you can look at any of the other places you want too, but notice that all these really dark places are record warmest. Okay? Here's the available data. Gray indicates an area where we have no data. Okay? And in fact, on any given day, if you take all the squares on the face of the Earth, we have temperature measurements in only 40% of them. And that's if all the sensors are working and everything is hunky and dory. All right? On some days, the number of squares that have temperature measurements gets down to only 25%. A whole lot of infilling going on. And just to check and see if their estimates were okay, this is the December microwave emissions. So this is brightness temperature. And brightness temperature isn't exactly temperature, but it's a good proxy. And the interesting thing is this shows basically normal temperatures in that area, not record temperatures. Okay? So what do you do? The truth of the matter is there's only one temperature set on the planet for which all the data used to create it is completely known. That data is completely available to whoever wants it. The reasons for adjusting that data are all known. And the code used to adjust the data is available. You can download it. And that's the University of Alabama, Huntsville data. It's microwave data. And the sad part of that is we didn't have microwave sounders before 1979. So it starts then. So it's a very short data set. I'm sort of a hardline physicist. This is not data to me. What purports to be the temperature of the world isn't temperature. If you can't tell me where your data came from and how you adjusted it, it's not data. I'm sorry. Okay, so the published temperature records are compromised. The world probably is warming. It's probably warming at about 1/4 degree per century. Okay, hopefully we're coming out of the little ice age. All right. The problem is that if we had a really good temperature record, then we could start to separate out the climate part from the CO2 part. But with a data set so compromised, we can't do that. So it's hard to draw any conclusions at all from the data sets that we have. Okay, well, so we claim that the world warmed, and all of this is due to man-made carbon dioxide. Well, the first thing we haven't considered is the fact that we're coming out of the little ice age. I mean, that should be there. And again, we don't know why these things happen, but it's real. The next thing is there are processes in the atmosphere. You've all probably heard of El Nino. That affects us in the United States quite strongly, but it's a very short-lived one. It's basically about a year, maybe 2 years long. But there are others. The Pacific Decadal Oscillation affects us in the United States very strongly, and it's a warm pool that ends up north of Japan and it comes and goes. And it comes and goes on about a 70-year cycle. Okay? And so what you have here is a sort of sine wave here that's roughly 70 years long. Okay? And it warms the world. There's another one that concerns you more, and that's the Atlantic multi-decadal oscillation, and that's a pressure difference between Iceland and Portugal, if I'm not mistaken. And that governs your temperatures on a very large scale. The interesting thing is none of our models can predict these at all. Okay? And so we don't take them into account. The other thing is the sun, and a lot of people poo-poo the sun because the output of the sun is more or less constant, okay? And so that if the sun's output is more or less the same, then it can't have an effect. But it's becoming increasingly clear that cosmic rays play some role in the formation of clouds. And the wind from the sun affects our ability to shield the world from cosmic rays, and it plays a role. And how that exactly works, we don't know yet. But it's clear that periodic cycles on the sun correspond to periodic cycles in our climate. But again, it's not considered. This last one is a sort of big one, and I just show the United States, and I'm going to center out Iowa here, because I use this in my class. In Iowa, historically, we grow soybeans and corn. And historically, we grow about the same numbers of each, and we swap them back and forth because corn uses lots of nitrogen, and soybeans puts the nitrogen back in the soil, so you don't need so much fertilizer. And now with ethanol, we grow way more corn than we do soybeans. And the albedo of corn is about 1%, or it's the difference between 0.21 and 0.23 for an albedo, so it's 10% difference. And that difference in albedo over the state of Iowa changes the net radiation over the state of Iowa as much as a doubling of CO2. Okay, and we don't talk about this at all, what we're doing to the land surface. And fully 70% of Iowa is corn or soybeans, so it's a lot. Okay, so now that we've convinced you we're going to have all these terrible high temperatures, that increase in temperature is going to have all kinds of negative effects. And this is where it gets really fun, because some of these get really wild. Back in 2001, the modelers in England predicted there would never be snow again. Okay? And it gets fun because the government in England then, since there's going to be no snow, we're not going to stockpile salt and sand for the winter. And give it a couple years, and we have 3 winters in a row where the entire England was covered in snow, and there's no stockpiles of salt and sand. And major malfunction. Which leads to the problem of falsifiability. I mean, normally when a theory or a model predicts something will happen, if that doesn't happen, we say the model is not true. And unfortunately, that's not what happens with global warming. And a great example is currently going on in California. Last summer, a whole bunch of universities were having all kinds of press releases about how the drought in California, which at that time was only 16 months long, was going to be forever. Global warming was going to make this a permanent drought. Now, 6 months later, we're having universities. Just last week, University of Arizona held a press conference saying that the flooding that's currently occurring is due to global warming. You can't win. You just can't win. All right, so we've been predicting that there'd be more hurricanes, they'd be more violent, and this is the hurricane accumulated energy. And I don't know, even when I squint, it doesn't seem to show a pattern to me. Sea level rise, we have to be concerned. I mean, I understand if you're Venice, but the sea level's been rising for the last 200 years and actually corresponds with roughly the end of the Little Ice Age. So floods are hard to measure, so if we look at flood damage, it's gone down, if anything. Drought events, they occur, they don't occur, but no real trend. Wet events, again, no real trend. Tornadoes, yeah, number of tornadoes has increased, and this was used by Al Gore in his movie, The Inconvenient Truth, to show that we have more storms. In truth, this doesn't come from the fact that we had more storms. In the United States, this is data from the United States, in the last 50 years, we've been installing weather radars. We now cover almost the entire United States. So tornadoes don't happen that we don't capture today. But that wasn't true in 1950. But if we compare something that is a constant, in other words, the number of very strong hurricanes, you can that's the red ones, you can sort of see that it's actually decreasing. I can show you a million of these, but supposedly we're all going to starve because global warming will cause the crops to die. But everything you look at, rice, corn, wheat, whatever, the productivity is going up, not down, the amount per acre. This one's kind of a fun one. This is actually comes from the Wayback Machine on the internet because it was taken down by the UN. About 15 years ago, the UN predicted that there would be 50 million climate refugees by 2010. Clearly didn't happen. All right, there's common problems. You read a million of these papers that come by, and the sheep in Scotland are a little bit smaller than they were 150 years ago, and that has to be global warming. And you read all these, and there's some constants that go through. We talked about the tornadoes and hurricanes, and it's just the change in the way we measure things. This is one of my favorites. One sample makes a trend. The polar bears are now endangered species, okay? And that happened because a worker for the Fish and Wildlife Service was flying in a helicopter over the Arctic Ocean, and they saw one polar bear in the ocean. And he wrote a paper extrapolating that to the point where the polar bear population is being destroyed. And, it got everybody going, and we actually declared them to be an endangered species. In fact, the people that study these things, there's something like 17 distinct populations of polar bears, 2 of which haven't been measured in the last 40 years, just because Canada is kind of a remote place and polar bears are kind of not nice. But the other populations are all increasing. Every last one is increasing. What is normal? It's true. About 40% of the glaciers in the northern hemisphere are retreating. Fact. Okay? But if you actually go look, you find that by and large, they've been retreating since about 1800. And we have records showing this. Okay? Again, roughly corresponding to the end of the Little Ice Age. All right? So what's normal? You see all these things, and they've been happening before, and they've, still happening. And the word unprecedented always occurs. And again, when you have issues, if you're a believer, and you've got something happen, the oyster die-off was a thing that people were believing that the oysters, they were having problems growing oysters on California, on our Pacific coast. And if you go to, say, for example, 350.org, lots and lots and lots of stuff about how this is because of global warming, and increased carbon dioxide makes the oceans more acidic, and the oysters can't handle it. Well, fortunately, in the oyster case, we have a group of people whose living depends on oysters, so they really got to know why. Well, it turns out there's a bacteria that was infecting these things, and it was killing them off. And in truth, CO2 did play a role. And the problem is that they were pumping water from the ocean off of our Pacific coast goes down very deep, very fast. And the ocean, the bottom of the ocean has a lot of nutrients in it. But the water at the bottom of the ocean is saturated with CO2. There's a lot of sources of CO2 at the bottom of the ocean, and basically it's all saturated. So they would pump this water up because it's so full of nutrients for the baby scallops, and then they'd warm it because it's really cold down there. So they take water that's already saturated with CO2 and thus a little bit acidic, and they warm it up to make it supersaturated and even worse, and then the baby oysters can't take that. And all they really needed to do was to let the CO2 escape, to let it sit for a while. But it wasn't global warming. It was the practices they were doing. Okay. The problem with the hype is that there are things that we need to do that way more important than CO2. Think, for example, the Chinese. The air quality in China is abysmal. And it affects the Koreas, Japan, and even some parts of the United States. It's that bad. Okay? But the Western world is concerned about one and only one thing insofar as discussing pollution with China, and that's CO2. And of all the immediacy of the problems, it's the wrong one. Okay? And it's leading us to do really environmentally stupid things. And if you really want to talk about these, I can, or maybe it's for another lecture, I don't know. But I'm going to argue all these things are really, they're worse than the problem they're trying to solve. There are a number of books out there that show you that if you really want to help people, you really want to lift people out of poverty, then there's a whole lot more we can do than trying to eliminate CO2 to help them, to eliminate poverty, to get people started, providing power. All right, to end. The predicted amount of warming is unlikely. The impending catastrophe is unproven. There's no indication that that's going to, things are going to get really bad. And I'm going to argue that if you want me to make extraordinary changes to my lifestyle, my economy, the way we do business, the way we're governed, then you need extraordinary proof that what you're saying is real. Okay? And it's not there. It's just not there. So I see no compelling need to remake our societies. Now, this doesn't mean that the atmosphere is a sewer. But a lot of the things that people are claiming we need to do, I just don't see it. All right? Thank you. I appreciate your time.
Thank you very much for this enlightening lecture. So, while this is not your, let's say, main field of research,
no.
It definitely is a very interesting one, and in my opinion, you covered it very nicely. So, are there any questions from the audience?
Surely I haven't convinced everyone. Sure.
Please.
Actually, I have to say, my colleagues and me were aware about all this you have told us. I'm not happy to say, but I have heard everything of it, but I like it to hear it again. Now the question, is there any hope that the paradigm is changed because of Mr. Trump? You know, it's our battle. We are also, here in Slovenia, we also have a small battle because money is flowing into renewables from our pockets, and nobody asks us anything, and we are really upset. And as far as I know, $4 billion each day is going into this climate change paradigms. And these people will not just give up because they want to be paid. How is the climate, I don't mean climate, but political climate, now as the new president has announced that all things with these climate changes is more or less a fraud?
Climate change is going to, the research is going to continue on some level, but for example, one of the big temperature data sets is maintained by the NASA GISS group. And there's a bill in the Senate right now that will eliminate that group and basically reorient NASA from climate change to deep space exploration. So yeah. The other thing I think that's going to change in the United States is we have invested a whole lot of money in renewable energy that I think has been squandered, and I think that's going to stop. We have a naval carrier group in the Pacific, for example, that runs entirely off of biodiesel fuel. And we pay $500 a gallon for that fuel. That's not something Trump's going to accept. No.
Yeah, but it's hope for Europe, because in Europe the situation is even more bizarre. The money flowing into the so-called renewables with no effect, absolutely. And it's obviously this physically, it's a nonsense, this warming. Everybody actually knows, except those who are religious, and there is no argument to convince them. So we hope that if in America things change, perhaps sooner or later will in Europe too. So
yeah. Well,
it's not a question, it's my comment.
No, I understand. And actually, I think what's going to happen in Europe is you're going to run into, we don't have enough solar and wind yet to really make a difference. I mean, it has increased our prices, yes. But Germany, for example, their renewables are destabilizing the electrical grid, and the countries around aren't really happy about that.
Yes,
and not to mention the fact that the Germans pay 10 times as much for their electricity than I do. And at some point, that's not sustainable. People are just going to say no.
ROA for methanol and for biodiesel is less than 1. And in modern society, it should be more than 14 if we want to have such a standard as we do have. And the problem is not Germany for us, but the problem is that the governments of especially small countries like Slovenia do exactly what the Germans say. So they are robbing us. Thank you.
Okay, please.
I'm a skeptic myself, so thank you for the nice presentation and confirmation of my views. But I will return to physics and ask two inconvenient questions.
Sure.
If I may. So to say, I would like to play a devil's advocate on both sides.
Yeah.
One thing is the linearity of thermometers that you mentioned. You don't have to have absolute accuracy because the linearity of thermometers is an order of magnitude better than their absolute accuracy. So in principle, when they are showing temperature anomalies, they're doing the correct thing.
Oh,
This
yes,
is one.
yes, you're comparing like things, I agree. But the fact is that the climate change models can't predict the current temperature.
Yes, of course. Yeah. Another question regards the greenhouse effect in the atmosphere. Can there be a greenhouse effect in the open atmosphere? I mean, if you heat up the atmosphere, it simply expands into space, and the radiation level, which is about at 5 kilometers, simply rises a little bit up and radiates more, and you have actually a neutral state.
Oh, but what happens is okay, so I have the Earth's surface here, and I have the atmosphere, and if I put water vapor in it, for example, the long-wave radiation from the Earth's surface is going to be absorbed by the water vapor, and that's going to warm this layer, okay? And this layer is going to radiate to space, and it's going to radiate down, and it's going to increase the amount of available radiation at the surface, so the surface will warm.
Yeah, but I mean, your graph with the satellite data shows exactly the opposite. So.
Oh, yes.
I mean,
so the problem is it's more complicated than that.
Yeah.
Yeah, sure, I agree. It's more complicated than that. And the feedbacks must be close to zero, if not slightly negative. Yes.
Miriam Duller, my question is about the adjustments of measurements, which you've mentioned, and I think I was lost in the middle of your explanation. Can you tell it again? Who is making these adjustments? How?
Two groups basically are making them. The first group is the group at NOAA. There's a central repository for temperature records for the planet, and the temperature records come in, and NOAA adjusts them, and there are scientific reasons to do some of the adjustments. But the problem is the net adjustments all seem to go in one direction, and that would not be the case. So NOAA does this, and they end up in the Global Historical Climate Network. Now, if you're, say, the Hadley Climate Research Unit in England, you take that data set from NOAA, and you now take that in, and you want to make a worldwide data set, a worldwide temperature, and you adjust it again. And so there's actually two groups that systematically adjust these things. And if it's not the Hadley Climate Research Unit, the NASA GISS people do the exact same thing, and they have a global temperature data set. And there's a Japanese group that does the same thing, and there's also the Berkeley group that does the same thing. So there's at least 4 groups that have worldwide average temperature measurements.
Somebody was measuring in, I don't know, in Fahrenheit, and another one in Celsius, and then they would put onto the same scale, but what are they doing? I still don't understand.
Well, some of the temperature, and some groups correct for this and some dudes don't. The Hadley guys do not correct for urban warming, but the NASA people do correct for global warming. So you remember I showed you the one where the 2 stations 100 kilometers apart, and one has a very strong warming trend and the other one actually has a cooling trend? Well, what they try to do is they try to take that warming trend out of the data because it's an urban data set. So they try to take that out. Another one is time of observation. It turns out that you get different trends. If I have a thermometer here, and if I sample every morning at 6 o'clock, I get a slightly different temperature trend than if I sample every day at noon. Okay? And so you correct for time of observation. The other one, and the one that there's the most discussion on, is it's called homogenization. Some data sets for temperature have not had the same instrument or been in exactly the same place for their whole history. And so what you have is a temperature record that goes by, and then there'll be a jump in the record because I have a new instrument. And so what you really ought to do is move this whole section down so they match. Well, it's very difficult to go through the records of every temperature station on the planet and try and figure out when these are. So what they do is they look at the temperature records from the other stations for within 1,000 kilometers. And they look at that, and if there's a jump in the temperature in this record, but there's not a jump in temperature from the others, then they know that there's something wrong with this one. Okay? And it's the homogenization procedure that produces most of the increases in rate of temperature increase. Does that make more sense?
Yeah, I think I understand it now, but still, those people who are making these measurements should be scientists. So they should be honest, fair, objective, and so on, don't they?
Should be. I mean, we have one of the group saying that it was fraud. I mean, and there are other things. I mean, the hockey stick, you're all familiar with the hockey stick? I mean, we could talk for a whole evening about the hockey stick. I hate to use the word fraud. I really do. Because you're right, scientists are expected, but the level of whatever scientific integrity of the people who did the hockey stick is not at the same level that I would hope we would be. And there's lots of examples of this. Sorry.
Okay, so what you are saying is global warming is a lie, clean energy is a nonsense, and we should keep burning oil and coal.
The lie is a very strong word, okay? I mean, you know, on some level, the climate models are very poor, all right? But I'm a big believer in you do what you can do when you can do it. And technology and abilities change, and over time we get better and better and better, okay? What I'm complaining about is on the basis of your models, you want to completely change how we live and our economies and how they work. And I'm going, no, you know, the proof is not there. Clean energy is not so clean. I can show you that the use of windmills actually increases the amount of carbon dioxide in the atmosphere over not using them, okay? That's a provable, that's a fact, okay? It's also got problems because it's not reliable, okay? You know, South Australia, the state of South Australia, it's right in the center on the bottom. 5 times the entire grid has collapsed since last August. And it causes great damage to a whole lot of things. There's one of the places is a smeltery. And so they've got all these electrically heated ovens with this molten metal in it, and they're trying to force metal to do all this stuff, and the power goes away for a week, okay? And they're left with basically solid metal in their foundries, and it's like, you know, now what do we do? Start over. And it's caused by the fact that South Australia, the state of South Australia, went big time into wind power. And when the wind doesn't blow, you have a problem. Another example of clean power, okay? The British built a huge complex that supplies most of the power for Britain literally on top of coal mines. So it doesn't have to be shipped anywhere. They just got to bring it to the surface and burn it, okay? But now, because of the European rules, we have to burn clean. And somehow burning clean means that we cut down trees in North Carolina in the United States, we chop them all up, we load them aboard ships and ship them all the way to Britain, where they burn these wood chips to make power. it's not as, you can't burn wood chips as hot as you can burn coal, and so it's not as efficient. Okay, so right there, you're burning, you're putting more CO2 into the atmosphere than you were before. And in the long scheme of things, it's just, you're doing more environmental damage than help.
So what's the interest of all these scientists who are lying to all us?
I don't know. Lying is such a hard word.
They are not telling the truth.
Well, there was a report that came out. A whole bunch of different agencies in the United States got together and they produced a report. This is about 6-7 years ago. And a really good friend of mine, who is the director of a laboratory in Ames, Iowa, and I work with him, and I mean, we're co-authors on probably 20 papers, was one of the authors of this. And this paper said, we're already seeing the effects of global warming, and it's a disaster, and we've got to do something now. And I called him, and I go, Jerry, what's going on? I mean, I know you don't believe this. But his answer is that I'm responsible for 123 scientists and their jobs. If I am seen as not being on the same sheet of music as everybody else, then I'm going to lose funding and those people are going to be without jobs. I don't have a choice. I mean, that's the situation you find yourself in.
Thank you for doing justice to this topic, but I have a question for you. It's obvious that the greenhouse gas, the major greenhouse gas is the CO2, and I want us to look at it from another perspective, that we also have some other greenhouse gases, like the methane and the nitrous oxide. Has there been any research work to ascertain the effect of these other greenhouse gases?
Oh, yes.
Apart from CO2?
Oh, yes. Yes, people do research on the other gases. Yes, that's true. And even like it turns out that the gases that they use to put you under, for surgery, turn out to be really serious greenhouse gases. Yeah, people do research on that. But in truth, their greenhouse effect is small in the larger scheme of things. It's just between carbon dioxide and CO2 and ozone, you cover most of the long wave spectrum. Yeah, Clement. Now comes my hard question.
No, not really. Clement Bergant. Bill, you correctly exposed problems of climate modeling that we are aware of. And there are many, many uncertainties related to climate modeling. But of course, also modelers are usually physicists who try to do their best with available limited knowledge.
Agreed.
And the models show, I wouldn't say uniform, but somehow similar trend. Are you aware of any modeling group that would somehow confirm your results in a way that...
No, although I would point you to a research article. It was done by a group in Los Alamos, and I'm trying to remember the name of the guy who did it. But they looked at all the models, and their conclusion was that the models are more like each other than they are like the real climate. I mean, your models...
So that the theory in more or less all the models, it's pretty much the same.
Say again?
So that the theory that is used to produce those different models is pretty much
uniform throughout the models, yeah. What's mostly different is how you tune them to match past history. Yeah. Now, I beat on the guys with models, okay? But again, you do the best you can when you can do it, and as time goes on, we learn more, and we do better, and we do better. And yeah, what I'm objecting to is changing everything about the way I live based on a model that just isn't right.
But
Okay?
no model is right, because it's just a simplification
Yes,
of
but
the
some
real
models
nature.
are useful.
Some models are better than the other, that's true.
Yes. Yes. Yeah. Sure.
Can you say a few words about the third source of energy? I miss nuclear energy from your speech. Very simple. It's the cleanest energy, nuclear energy. It's the safest. In Fukushima, one was dead by radiation. In Chernobyl, maybe 100. That's much less than the digging coal.
Yeah.
And nuclear power should solve all these simulations and all these calculations. I agree with you, but at least for $4 billion per day of stupid eco-terrorist money, we should build much more nuclear power stations, and we could make them much safer if somebody feels that they are not safe. I believe they are.
Yeah, I agree with you. I actually was licensed as a nuclear engineer at one point, so I'm a believer. And I would argue that, yeah, a lot of people got hurt over the Russian one in Chernobyl, but I would argue that was, the Russians were irresponsible. Those kind of reactors should never have been built. And I can go into that in some detail being...
$4 billion per day
Yeah.
to build a better state.
Someday they will vote me God Emperor and I'll change this. Yeah, I agree. Yeah, and nuclear power has its own limitations. You know, and at some point we're going to figure out how to do fusion power, and pretty much that will solve our problems. But in the meantime, until that day happens, I mean, nuclear power is certainly a good alternative. Yeah. I'm sorry? Yes, thorium reactors is... Yes. Well, there actually are designs out there. Yeah. Yeah. And yeah. Well, and yeah, the plutonium you'll get from a commercial reactor, you can't use to make a bomb. It turns out.
Yes, but you can make dirty bomb. Just make dust from this, and
Yeah.
you know,
Yeah.
it's somehow a political issue. But if you don't have plutonium, then and if you burn thorium, you don't get plutonium.
Well, you'll still get radioactive waste. I mean.
Yes, but much less than the commercial uranium reactor.
Okay. Yeah. I mean, we quibble. Yeah.
For this money, they could do it.
Yeah. Yeah. It takes political will, though. I mean, in the United States, we have not built a new reactor since 1979. It's political will. It's not technology. It's not anything else.
Yeah.
Oh. No.
So, Bill, if we draw the line, the message of your lecture is that we should learn something that we don't want to learn, to use a common sense. Yeah.
Yes.
So, not to produce technologies which consume more energy than they provide.
Yeah.
Use biofuel when where it's available. Produce biomethanol where you don't have to input a lot of energy, like in Iowa, for example, Brazil, Slovenia for wood chips, perhaps.
Yeah.
And this would turn our atmosphere into something which I like the most at the end, not into a sewer. Yeah?
Yes.
That's what
No,
we
I agree.
would all like.
The energy for ethanol, though, comes from the fact that you have to distill it, and that's where you put in a lot.
Okay. Well, thanks for a great lecture.
Thank you.
So thank you.
Thank you.
I think we can
Thank you
finish
all.
with the questions. Thank you very much.